So essentially, if you're going down a hill on a sled, it's an inclined plane, right? It's an incline, so it's an inclined plane. Okay, so what we have is a not very steep hill. Well, 25 degrees is pretty steep, steeper than you would think. Okay, 25-degree angle, and we have the 50-kilogram child. Okay, what forces are acting on them? Gravity. Okay, gravity's one, and it goes this way. Friction. Which way is friction act? Right, up the ramp because they're going down. Okay, so friction is this way, and we know it's 150 newtons. Okay, what other force should go on the box? Right, F parallel should go on the box. Okay, now F parallel is not a separate force, it's the sum of gravity and normal force. That's that little triangle that goes inside that we have to remember. This is normal force, this is F parallel, okay, and F parallel is the vector sum of normal force and gravity, with this angle being the same as the incline. So we got to calculate that first. So the force of gravity on a 50-kilogram child is 490.5 newtons. Everybody okay with that? All right. Then we can find F parallel as it's the opposite side of this triangle with gravity being the hypotenuse. So we would simply take the sine of 25 degrees and multiply it by 490.5 newtons. So F parallel in this case is 207.294 newtons. All right. That's all the forces that should be there. I've taken into account normal force and gravity, okay, and this is actually a very common mistake. I've taken them into account and written them right here. They are no longer a factor. Does everyone follow me on that? Okay, because what I often see people do when they're doing the sum of all forces is they do this. F parallel plus friction plus gravity plus normal force. Okay, we already took these ones into account. That's what F parallel is. All right, we would not include these later. We already found their vector sum, right? And that's a common thing that I see happen. All right, so we don't want to do that. So now F net is F parallel plus the force of friction. And I have both F parallel and the force of friction. So, okay, my net force is going to be 57.294 newtons down the ramp. Or down the hill. I guess not a ramp, it's a hill in this case. Downhill. All right, everybody with me there? All right, can I now calculate the acceleration of the 50-kilogram child? Yes. Okay. So now I'm going to use F net equals m times a. All right, and so acceleration will be 57.294 divided by the mass of the child, 50 kilograms. All right, so all right, so we've got 1 point, we only have two significant figures here, so 1.1 meters per second squared downhill. Okay, basically, guys, all inclined planes are going to involve the same steps. Those steps won't always be in the same order because sometimes they'll give you acceleration and ask you for a force, okay? Or in this case, they gave you all the forces and asked you for acceleration. So it's always the same steps, you just sometimes perform them in a different order, right? But when it all comes down to it, basically all inclined planes are the same. That internal triangle is the part we have to remember. Now, if you wrote on this answer 1.1 meters per second squared down, would you get it right or wrong? Is down the same as downhill? No. Okay, there's a 75-degree difference between down and down this particular hill. Okay, down is straight down. That means the child is falling through the hill towards the center of the earth. That is not what they are doing. Okay, they are going downhill, which is different. Okay. All right, questions on how the inclined plane works? Okay, so the questions that are on that worksheet we were working on yesterday are going to start becoming more involved. The ones we worked on yesterday, like up to kind of question 10 or 11 or so, are like pretty basic. Right? Following that worksheet, there's two other ones. One is force as a vector quantity. Okay, there's a lot of vector stuff on that one, hence the name. Okay, there's some system stuff on that one, things like that with pulleys, etc. And then there's one that's just all on inclined planes. Inclined planes are my favorite kind of Newton's second law problem. Not that that's really, like, you're probably going, so what, Coder? Well, I'm the guy who makes up the test. Remember that inclined planes are my favorite kind. That might serve you later. Okay. So we're going to spend some time working on that on tomorrow. I was going to say on Wednesday, but that's tomorrow. Okay, we're going to be kind of looking at possibly doing the Newton lab tomorrow. Okay, that'll involve a pulley situation. Okay, so kind of like those problems that we were working on the other day. Right. So what I want you working on here now is just some more stuff from that worksheet. I'm going to come up with a couple of other kind of new situation problems while you're working, and we'll do those, okay, periodically as we go through. Right, so I'll put that worksheet back up. Okay, but I want you working a little further on it, even if you're not quite on the last few questions. I'll just put those ones up and you can work on those.